State the maximum or minimum value of each quadratic function, correct to nearest hundredth, and the x value at which it occurs. So the first one is y equals 3x squared minus 4x minus 5. We start by factoring out the greatest common factor from the first two terms, which is 3, and that leaves us with x squared minus 4 over 3x. Now we complete the square. So we're going to take 4 over 3x, 4 over 3 divided by 2, and we're going to square it. So that's going to be 4 over 6 squared. We added it, and we're also going to subtract it. And now we have our perfect square trinomial. So we can go ahead and factor it. Which is going to be x minus 4 over 6 squared minus 4 over 6 squared minus 5. Next, we bring the GCF 3 back into the bracket. So that's going to give us 3 times x minus 4 over 6 squared minus 3 times 4 over 6 squared minus 5. So at this point, what we could also do here is we can reduce these fractions just to get some smaller numbers. So let's just rewrite this with those fractions reduced. You can divide numerator and denominator by 2. We get 2 over 3. Like that. And in the next step, we need to evaluate the last part here, the numerical constants. And if we do that, we're going to get the last part here. It's going to be negative 19 over 3. We just square that quotient, multiply the numerator by negative 3, and then we subtract 5. So if we look at this vertex form, we can see that the coefficient here, 3, is larger than 0, which means that this quadratic function opens up. Which means that it has a minimum. And the minimum, the y-coordinate of the minimum, so the minimum is at, the y-coordinate of the minimum is going to be the negative 19 over 3. Now they want the answer to nearest hundredth, so it's going to be 19 over 3. So it's going to be at negative 6.33. And the x-coordinate of the minimum is going to be positive 2/3. So again, to nearest hundredth, that's going to be 0.67. In B, we have y equals 1/3 x squared minus 4x plus 10. Our greatest common factor from the first two terms is going to be a third, which leaves us with x squared minus 12x plus 10. We complete the square. So we take 12 divided by 2 and square it. That's 36. So plus 36 minus 36 plus 10. We now have our perfect square trinomial right there. So we go ahead and factor it. And that's going to be x minus 6 squared. And then we have minus 36 and plus 10. Now we bring the 1/3 back into the bracket. So we're going to get 1/3 times x minus 6 squared. And 1/3 times 36, or negative 36, is negative 12 plus 10. We clean it up and combine like terms. Negative 12 plus 10 is negative 2. So because this coefficient here is greater than 0, it means that the quadratic function opens up, which means that it has a minimum at the y-coordinate of negative 2. And the x-coordinate of that minimum is going to be positive 6. So that's B. Let's have a look at C. So in C we have y equals negative 0.25 x squared plus 2x plus 3. So we need to factor out the greatest common factor from the first two terms. That's going to be negative 0.25. So if we factor that out, we get negative 0.25. And then we're left with x squared minus 8x and plus 3. We complete the square. So we take 8 divided by 2 to get 4 and square it to get 16. So plus 16 minus 16 plus 3. Here is our perfect square trinomial. We can go ahead and factor that. So we're going to get negative 0.25. And we have, if we factor the perfect square trinomial, we're going to get x minus 4 squared minus 16 plus 3. We bring the negative 0.25 back into the fold. So we're going to get negative 0.25 times x minus 4 squared. Negative 0.25 times negative 16 is positive 4 plus 3. Cleaning this up leaves us at 0.25 times x minus 4 squared plus 7. The numerical coefficient here is less than 0. So it means that the quadratic function opens down. And it means it'll have a maximum at, so the y coordinate is 7. And then the x coordinate of that maximum is going to be positive 4. And finally, we have y equals 2x squared minus a quarter x plus 1. We factor out the greatest common factor from the first two terms, which is going to be 2, leaving us with x squared minus 1/8 x, and then the plus 1. We complete the square, so it's going to be x squared minus 1/8 x, and then we divide this quotient by 2, so it's going to become 1 over 16, and we square it. So it's going to be 1 over 16 squared minus 1 over 16 squared plus 1. So now we can go ahead and factor this perfect square trinomial that we have here. So we have a 2 times. So if we factor this perfect square trinomial, we're going to get x minus 1/16 and then squared minus, and at this point I'm going to evaluate the following quotient. So I want to square it. So it's going to be negative 1 squared is just 1. 16 squared is 256 plus 1. We combine, now we multiply everything by 2. We bring the 2 back into the bracket. So it's going to be 2 times x minus 1 over 16 squared minus 2 over 256 plus 1. We combine the last two terms here, the numerical constants, and we're going to get 2 times x minus 1 over 16 squared. And if you combine those terms and simplify these terms here and simplify, we're going to get minus, it's going to be positive, 127 over 128. Now they want to answer to nearest hundredth, so actually we are going to divide those numbers. So so in this case here, because this coefficient here is greater than 0, it means it opens up, and that means there is a minimum at, so the y coordinate, that's this coefficient here. So if we divide those numbers, we're going to get, so the minimum is at 0. To nearest hundredth, 0.99, and the x coordinate at the minimum, again to nearest hundredth, so 1 divided by 16 is 0.06.